Today's lesson, Tollens reagent and its importance. In this lesson, we are going to learn definition of Tollens reagent, preparation of Tollens reagent, importance of Tollens reagent, and finally, reaction mechanism of Tollens reagent. So, let's get started. The very first point is definition of Tollens reagent. Let's look at the matter. Suppose this is the solution of silver nitrate and ammonia, which is called ammoniacal silver nitrate. Ammoniacal, that means containing ammonia. Here sodium hydroxide is present. So this is the solution of Tollens reagent. That is, Tollens reagent consists of silver nitrate, ammonia, and sodium hydroxide. Chemical formula of Tollens reagent is diamine silver hydroxide. This solution contains actually silver ion. This is the Tollens reagent, a solution of silver nitrate with excess ammonium hydroxide. Its formula is diamine silver hydroxide. Solution contains silver ion, which is the main component of the solution. Silver ion acts as oxidizing agent. That is, Tollens reagent is used as oxidizing agent. Let's move on to the next point. Tollens reagent. How is this Tollens reagent prepared? Let's look at the matter. Equal volumes of 10% silver nitrate is taken and 10% sodium hydroxide. From these components, light brown precipitate of silver oxide is formed. Silver oxide is formed as precipitate, light brown precipitate. Sodium nitrate and water are formed as byproducts. So, from the first reaction, precipitate of silver oxide is obtained. In this solution, that is, in which silver oxide deposits as light brown precipitate, here excess ammonium hydroxide is added. Concentrated solution of ammonia is added to the solution, in which silver oxide remains as precipitate. Ammonium hydroxide is added until silver oxide dissolves completely. Then this is obtained, diamine silver complex, diamine silver hydroxide, and byproducts are ammonia and water. Diamine silver hydroxide, which is soluble in the solution. Diamine silver hydroxide, the chemical formula of Tollens reagent. And Tollens reagent is prepared through these reactions. Now let's see importance of Tollens reagent. Now the point is importance of Tollens reagent. The reagent, which is named Tollens reagent after its discoverer, German chemist Bernhard Tollens. Now let's see importance of Tollens reagent. We have learned from the previous lesson 2,4-DNP, which is used to detect aldehydes and ketones. That is, 2,4-DNP is used to detect both aldehydes and ketones. Simply, we can say that aldehydes or ketones, 2,4-DNP is used to detect carbonyl group of aldehydes and ketones. 2,4-DNP cannot distinguish aldehydes from ketones. Here, Tollens reagent is used to distinguish aldehydes from ketones. This is the main importance of Tollens reagent, to differentiate aldehydes from ketones. Tollens reagent reacts with aldehydes, but Tollens reagent doesn't react with ketones. Let's see the reactions. Aldehydes, suppose this one, ethanol. This is treated with Tollens reagent. Then the reaction mixture is heated at 40 degrees Celsius temperature for 2-3 minutes. Then silver ion present in the solution deposits as solid silver on the inner wall of the test tube. That is called silver mirror. Here, byproducts are ammonium acetate, ammonia, and water. Metallic silver that deposits on the inner wall of the test tube is known as silver mirror. This silver mirror confirms the presence of aldehydes. This is the Tollens reagent test. Let's see another reaction. Suppose formaldehyde. Tollens reagent, diamine silver hydroxide. Here, formaldehyde reacts with Tollens reagent, then silver mirror is formed. Here, formaldehyde turns into ammonium formate, ammonium salt of formic acid. Byproducts are ammonia and water. Here as well we see that Tollens reagent reacts with aldehyde to form silver mirror. In the first case, Tollens reagent reacting with aldehyde ethanol forms silver mirror. But this Tollens reagent doesn't react with ketones. No reaction. This is the importance of Tollens reagent, which is used to distinguish aldehydes from ketones, producing silver mirror on the inner wall of the test tube. That is, these hydrogen of aldehydes play an important role in this reaction to form silver mirror. But when ketones are used, no hydrogen is present in ketones. That is why ketones cannot form silver mirror on the inner wall of the test tube. That is why ketones do not undergo Tollens reagent test. Here we learned that hydrogen atom of aldehydes plays an important role. Let's see reaction mechanism of Tollens reagent. Now let's see reaction mechanism of Tollens reagent, in which Tollens reagent acts as oxidizing agent, and at that time silver ion of Tollens reagent reduced to metallic silver. Let's see mechanism. Aldehyde, suppose ethanol. Here electronegativity of oxygen is 3.5. On the other hand, carbon is 2.5. Because of the high difference in electronegativity between carbon and oxygen, pi bonded electrons move towards oxygen, and as a result this is found. Hydrogen, here negative charge, carbon positive charge, 2 electrons, that is pi bonded electrons move towards oxygen. 1 electron of oxygen and another electron from carbon. That is why over carbon positive charge and over oxygen negative charge. Now silver ion that remains in the Tollens reagent. Silver ion takes 1 electron from this ion and it deposits as metallic silver. And here what is obtained from this ion? Let's see. Plus CH3, H, here oxygen, free radical, carbon plus. That is, from these 2 electrons, silver received 1 electron and 1 electron is left here. Then hydroxide ion. In Tollens reagent, sodium hydroxide is used to maintain basic pH of the solution. This hydroxide ion combines with this positively charged carbon. Then this is obtained. 1 electron, here hydrogen, OH group, hydrogen, OH group. This oxygen contains 1 electron. For this reason, this carbon-hydrogen bond undergoes a homolytic fission. That is, 1 electron of this carbon-hydrogen bond moves towards carbon and another electron moves towards hydrogen. And as a result, this carbon-hydrogen bond breaks. After that, this hydrogen gets freed as free radical, which combines with this oxygen free radical. Then this is obtained. CH3, OH, here OH, carbon with 1 electron. Here carbon receives 1 electron from this carbon-hydrogen bond. Then it is now carbon free radical. That is, carbon contains 1 electron. Again, silver ion receives that electron to form metallic silver again. And then from this ion, this is obtained. CH3, OH. Now this carbon gets positively charged after losing this electron. Here OH. Then OH from the solution combines with this hydrogen to form water. that is removed from the reaction. Then this is obtained. Here minus OH. Then in this ion, this carbon is positively charged. Carbon is positively charged. Now here, this lone pair of electrons turn into bond pair to vanish this positive charge. Then this is found. Double bond oxygen, here OH. That is, acetic acid is obtained, which in turn turns into ammonium salt of acetic acid. This is the byproduct of the reaction. But at the middle, we get silver, metallic silver, that deposits on the inner wall of the test tube, which is called silver mirror. This silver mirror indicates the presence of aldehydes in the solution. Here, hydrogen plays an important role. That is, in this case, we see that carbon-hydrogen bond undergoes homolytic fission. This hydrogen gets freed as free radical that combines with oxygen free radical. But if we consider here, this is ketone, then there is no hydrogen, no reaction like this, and no formation of silver mirror. So if it is ketone, then no silver mirror. If it is aldehyde, then silver mirror is formed. This hydrogen, aldehyde hydrogen, is responsible for making silver mirror. If it is ketone, no hydrogen is present, no silver mirror will be formed, because here homolytic fission occurs. Homolytic fission between carbon and hydrogen. Electronegativity difference between carbon and hydrogen is not much. That is why here there is a scope to undergo homolytic fission. But if it is ketone, then alkyl group is electron donating group. No homolytic fission will occur and no silver mirror will be formed. This is the importance of aldehyde hydrogen, and because of this, aldehydes undergo Tollens reagent test, but ketones do not give Tollens reagent test. In this reaction, silver ion receives electron from aldehyde. That is why silver ion in this reaction acts as oxidizing agent, and silver ion oxidizes aldehyde to acid, and at that time silver ion reduced to metallic silver. That is, in this reaction, silver ion, Tollens reagent, acts as oxidizing agent. This is all about Tollens reagent and its importance. No more today. Thank you very much.